In this tutorial, I will going to show you how to set up the STM32 development environment under Windows 10 with VSCode and Windows Subsystem Linux. The board we use for this project is STM32 Nucleo with microcontroller STM32F042. And it's a super tiny board with STA link V2.1 embedded inside, which means with one single USB cable you can program the board, and you can also communicate with board through the virtual serial port. And the first thing we need to do is to install the Ubuntu on Linux. So if you don't know how to do this, there is a very detailed tutorial from Microsoft. The next thing we need is VSCode. So we will edit our code here. We will basically, it's our development environment. And also we will need STM32 Cube, which is a code generator. It have graphic user interface for help you to configure the microcontroller and generate corresponding code automatically for you. And the last thing we need is STM32 Cube programmer for STM32. Actually, we just need to install this software so that we have the driver for the ST link. That's it. We will later program all our board through the VSCode. After you install all of this, so you can start the STM32 Cube MX. And the first thing you need to do is to install the software package. As we use STM32F0, so you will need to download this MCU package under STM32F0. So after that, you can start to select your microcontroller. So in this user interface, we just type in the microcontroller part number, which is STM32F042K6. Actually, you can say this is the port we use, but we want to make things simple, so we just choose the microcontroller instead of the board. Now we have this user interface for us to make configuration on our microcontroller. So in this demo, I will do a very simple work, which is just blink the LED. So the first thing now is we need to know the LED on this PCB board, connect to which GPIO. If we go back to the website, we can, from the documentation, we can download this one, nuclear board. And we don't need to download it. If you go to very bottom, then you can find that the LED, user LED is connected to PP3. So that's all we need to know. Then we can go back to this configuration user interface, and we find PB3. And this will be our I/O connect to the LED. So we want to drive the LED. In this case, we need to set this to output. And we can also give it a name like LED. After that, there is a few things we need to set up. First, we will need to debug this like a microcontroller. So we enable the serial debug port. And next, we need to do some configuration on our GPL to LED. So in this case, we want it to be push-pull output mode, which is already here. And the output level by default, we make it low. So that you can see from the schematic, if we make a default low, the LED is start with not turning on. After that, we can keep the clock configuration by default, which looks good, and then we move to project manager. So basically, this is where the magic happens. In this case, we don't want to use any KOMDK, True Studio, or STM32 IDE. We want to use with VSCode. So in this case, we're using makefile, and we give it a name. Maybe let's say just LED, and we can keep the structure as basic. After that, we can set the code generator with all the library as a link, so we don't need to copy every time like all this library into our folder. And this extra advanced setting is asking you like which library you want to use for referrals. So in my case, I prefer to use low level, which like the library will be a little bit difficult to use than the whole library, but it's more flexible and it have super small code size compared to the whole library. So now we can click generate code, and it will starting to copy anything into one folder. Okay. So now the code is generated. If you already installed the VS Code, now you can already open this project. So it's look like this, and the main file is here, and the make file is also you can start to play with. So before we touching anything, the first thing we need to do is to set up the environment in VS Code, so we have the auto completion and all these similar things like help us to code in VS Code. We go to the add the C++ editor edit configuration. And in here, we need to tell the VS Code where to find all our libraries. And actually, all this library already showed in the makefile. So we just copy this library directory into that place. After that, we also need to define define there, because we're using the low-level driver. So first thing we need to copy there is low-level driver. The next thing is level controller factor number. So after doing this, now if we're going back to the main file, we should have the auto completion function ready for our to use. For example, we can test the delay function, which is delay. So you can see it's already showing up right now. So now we can start to write code to blink our LED. So first we set the GPL. And the LED port, we set the name of LED, so it's already here. So now it's reset. So turn the LED off, wait 1 second, and then we turn the LED on. And wait 1 second. Now we can actually compile the code, but before that, we need to make some change to our makefiles. You can say in this makefile, all this included directory and the source file. Oh, source file is here. We start with C driver, so which is a location in Windows 10. How this library stored in Windows 10. However, we need to compile all our code from Linux on Windows. So we need to using the Linux way to specify these locations and files. So in this case, we need to change all this part with so that's it. So now the source code changed and include folders changed. One thing you have to done before compile the code is you need to make sure you have the GCC installed on your Linux. So install it, just type the command GCC. Yeah. And you just install it. In my case, I already installed it. So you can try if you install the IDE-gcc successfully. So you can, if you can see this information, these two is already installed successfully. Then you just can shut it down and back to our make file. So now we can try to compile our code. So the good thing about VSCode is we can just start a terminal here. And if we want to use Windows subsystem Linux, we just type WSL. And so immediately we go to the Linux part. And now you can see actually the file location is the same. So we simply can start to make our project now. Okay, so now the hex file is, the binary firmware is like successfully generated. Now we can download this firmware to our microcontroller to run it. We still want to run the same thing here in this without leaving this terminal. So we just need some extra command to put inside our make file. So I will simply copy it here. Test. Now I turn on my camera. You can see I already connect the board to my computer with a USB cable. Then we can make download and hit the enter. Now you can see the code. The firmware is successfully downloaded to our target, and the app is running now. So you can see we edit our code in VSCode, and we set up like how we make our project and compile our project inside VSCode, and we also compile our code inside VSCode, and in the end we download our firmware to our target microcontroller board inside the VSCode. So it's actually simple compared to using other IDE, and it's more elegant. Okay, so this tutorial is end, and later I will also do some tutorial on how to use other STM32 peripherals like serial port, SPI, I2C, this communication bus, and all the future project will like develop under VSCode with the help of Windows subsystem Linux. In the end, with the camera on, I just change the delay to, let's say, 3 seconds, and to show you the whole. Oh, sorry. 3 seconds. Save the files and make again. So this time is the real time, and make ST link download again. So our board is now running with the new code. So LED blink every 3 seconds. That's it. Thank you.